Welcome students. Here we'll go with question number 3 on calculation of base shear for the multi-story building. In this question they have given as a 4-story RC frame building as shown in the figure is situated at Chennai. So that Z value is given as located at Chennai. So Chennai is lying in which zone? That is what we should know that. And the height between the floor is 3.5 meters and each of these are 3.5 meters here, and total height of the building is 14 meter. Total height of the building is 14 meters. 7.5 3.5 into 4 will be 14 meters. The dead load and normal live load is lumped at respective floor, so that here they have given total load. So here no need to calculate live load on the floor. So here they have given directly the total load on roof and on each floor. The soil below the foundation is assumed to be hard rock. Then SA by G is given as hard rock, right? And assume building is intended to be used as hospital building, so that I will be given as hospital building. Determine the total base shear distributed lateral force as per the code IS 1893. So here the total weight will be equal to 3 times 3000 plus 2500. 3 times 3000 plus 2500 will be 11500. 11500 is the total load, that is total seismic load of the building, that is W equal to 11500 kilonewton of total force. And here W is more than enough, here we have calculated, and H needs to be calculated, Z by 2 and I by R, Z by 2 I by R, and SA by G, and SA by E is to be calculated. Here Z is given as Chennai, so let us see in which zone the Chennai is lying here. So whenever the city is been given for the zone value, just go to the last page of your code book. In that pages the city name is given. Let us check here, right? In the page number 36, the city names are given alphabetically. So Chennai is lying here, Chennai in zone 3. The city or town is lying in zone 3, that is the value of zone is 0.16. Whenever the city is been given, then go to page number 36. In that page the name of the city and zone factor values are been given. So for this, Chennai is lying in zone 3, 0.16 is the zone factor value, so that 0.16 is the zone factor value, and importance factor I, that is I need to be considered for hospital buildings. So for hospital buildings it might be 1.2. Let us check in which importance factor the hospital building is located in the code. Right here it is given in table number 8. Right here table number 8, it is given residential commercial building. No, it is not there in 1.2, it is there in 1.5. Important service building and community buildings or structures, for example critical governance buildings, schools, signature buildings, monument buildings, lifeline emergency buildings, for example hospital buildings. So here hospital building is located in serial number 1. That serial number 1 gives I value as 1.5, right? So that I is 1.5, and here for R value, response reduction factor is not, I think it is not given. A 4-story RC building shown figure situated, height between floors, dead load normal, so that here R value is not given in the code. so that it is need to be considered a special moment resisting frame, because this particular structure is located in 1.5 importance factor. So that based on the importance factor we can consider this SMRF or OMRF. So once it is located in 1.5 we can consider SMRF. Once it is not located in importance factor as 1.5, either it is located in 1, so that you can normally consider SMRF or OMRF. Just we should mention the particular assumptions we have been made on the structure. Right, I have assumed that the structure is constructed with special moment resisting frame, and the R value is considered to be 5, and SA by G is given for hard rock, and again for this hard rock we need to calculate TA value, and to calculate this TA value here the base dimension is not given, so that you can use 0.075 to the power h to the power 0.75 again, so that h is 14 here. Let us calculate TA. 0.075 to the power 14 to the power 0.75, that is given with 0.54 again, 0.54 seconds. 0.54 seconds. Once the TA is calculated for hard rock, then we need to calculate SA by G, or we need to see the value of SA by G in the table. It is given here. SA by G for hard rock, again it is lying in 0.4 to 4 seconds, that is 0.54, that is lying in 0.54. So 1 by T is 1 by 0.54, and that is given with 1.85, and that will be 1.85. that is 1 by T is there in the code, because for hard rock SA by G for hard rock it is lying time period 0.4 to 4 seconds, so we need to consider 1 by T. This 1 by T is 1 by 0.54 will give you 1.85, right? So let us calculate AH. 1 point, that is Z by 2.16, 0.044, right? And we should multiply AH into W. Once we multiply AH into W, BB, that is base shear, is equal to 11,500 into 0.044, 11,500 into 0.044, that will give you 506 kilonewton of base shear. 506 kilonewton of base shear. And similarly we need to calculate the distribution of this force to each of the floor. The same procedure is to be followed here, whatever we have done in the previous problem, right? So here the value of floors and the value of floors and the weight of each floor and height, and WIHS square and WIHS square dividing with summation of WIHS square. The same content that has to be followed in this question also. So here the roof load is 2500 and floor load is 3000, and floor height is 3 meters, and 3.57, that is 7.7 plus 3.5, 10.5 plus 3.5, that is 14.5. The floor load will be, floor height will be 3.5, 7, 10.5 and 14. Likewise we have to consider the floor heights, and here it is floor level 4, 3, 2, 1, right? And here the each floor load, that is 2500 for the that is roof load, and for 3 to 1 floor we have 3000 kilonewton of total floor loads. So here once we consider these floor loads, we can calculate the distribution of this 5506 kilonewton of base shear to each floor and the lateral direction. So this is more than enough to consider the problems on equivalent lateral force analysis. So let us have an assignment over this content and we'll end up with this module. Thank you.